All right, good afternoon to everyone. This is the third day of DevDays 2024, and I am conscious that I'm once again standing between you and our social event of the evening. So I'll try to keep this interactive, and I will also encourage folks, please raise your hand or shout out questions if you have things you want to ask as we're going along. That'll help keep me awake, it'll help keep you awake. Maybe I will start off just by asking a few audience questions, just show of hands. So how many folks in the audience have used an electronic health record system, been sort of at the keyboard of the clinician-facing EHR interface? Awesome, okay. How many people have signed into a patient portal? Cool, how many people have downloaded some kind of a standards-based file from a patient portal? Okay, how many people have connected a FHIR application to a patient portal? Okay, this is an audience that's done a lot of these kinds of things. How many folks have requested a copy of your EHI from an electronic health record vendor or from your provider? Wow, that's like at least 6 or 8. This is amazing. How many people have successfully received EHI? Anyone? One person's not sure or being reluctant? Was that a yes? No, 0. Okay. Really interesting. I have to say, after my experience, I did succeed, but I'm not surprised that so far we're sort of like 1 out of 9. So let me back up. What is EHI? This is a concept that has been introduced in the Cures Act final rule. So came into effect essentially, all right, let me back up. The goal is, we know how to standardize a good set of core data in the health record. Medications, problems, allergies, labs, and so on. But there's a very long tail of information that is maintained inside of electronic health record systems or maintained by healthcare providers that aren't well standardized today, that don't show up in your US Core data APIs. And we have this regulatory intent in the US that any patient should be able to get a full copy of their health record. That has existed under HIPAA for decades. There's a construct called a designated record set. And that is essentially any information that a healthcare provider maintains about you that could be used in clinical decision making. So it includes the clinical and the billing aspects of how providers are managing your data. It includes the notes they write, the observations they make, essentially everything that's being stored in some kind of system by the provider. The HIPAA concept of a designated record set is not tied to electronic records in particular. It's any records. It could be paper. And historically, the way that you would get a copy of your designated record set would be by somebody printing out a large stack of paper and handing you that stack. And it's basically free to ask for as a patient, but they might charge you a certain number of cents per page. And there's some guidance that restricts sort of how much you can charge. And it has to be tied back to the sort of time and materials required to produce that for you. Fast forward to 2020, we have this concept of an electronic health information export, or EHI export, that's introduced in the regulations. There's a piece of this which is simply a requirement for healthcare providers. If you're a healthcare provider and you're maintaining electronic health information about your patients, the patients can show up at any point and ask for a copy, and you're supposed to give them a copy. It's supposed to be complete and essentially has everything in that HIPAA designated record set that is electronically maintained. That requirement for providers came into effect October 6, 2022. So the final rule from that Cures Act in 2020 gave providers basically 2 years to get ready for this to happen, and October 2022 was when that requirement came into play. Doesn't say anything about the technology that's going to be used to make it happen. Now, at the same time, a requirement was introduced for EHRs, for certified electronic health modules that maintain electronic health information. Those modules also need to be capable of performing a software function of exporting the data. That has to work at the level of an individual to export one person's data, or at the level of a population to export everyone's data. And those rules came into effect at the end of 2023. I am still scratching my head about why we would introduce a requirement for providers to give patients an export while it's still over a year away that the providers are going to have access to software to do that step. So I don't really know what healthcare providers were doing in the interim. I didn't ask for a copy of my EHI until 2024 because I suspected they might not have the software they would need to give it in a clean way. What else to say about these criteria? For the single patient export, there's this idea that some kind of user of the system would be able to trigger the export. You don't have to go back to the EHR vendor and ask them to help. That user could be the patient, but it doesn't have to be. That doesn't need to be a patient-accessible feature, and it doesn't need to be available online. We'll get into that. For the provider population export, patient population EHI export, this one doesn't have to be immediate, so it doesn't have to be as timely. And it could involve some help from the EHR vendor. So an EHR might build a product where they say, the way that you trigger a population export is you call our help desk and we'll do this special thing for you as a one-time operation. That's allowed. And when it comes to the data formats, the only real requirement is that the data need to be complete and they need to be electronic and computable. And there's probably a lot of ways to interpret this concept of computable. But roughly speaking, the intuition here is if an EHR is maintaining some data in a structured table somewhere, well, you shouldn't just print it out into an image and then return the image, right? That would be a clear example of taking something that started as computable and rendering it less so. But it leaves a lot of room for interpretation and for different choices about whether you want to structure these data as a JSON object or a CSV, or even in some cases a PDF, if you can show that you've left enough structure in that PDF that you can consider it computable. And each vendor gets to make their own choice about how they want to export those data, what formats they want to use, but each vendor needs to provide openly available, publicly accessible documentation of their format. So they need to be able to communicate to potential receivers of these data in a clear way so that somebody who receives the data and reads the documentation would be able to put those things together and make use of the data downstream. That's the concept of EHI. And I should say, I was an advocate for this pretty early on, including comments to ONC on the way into this Cures Act final rule, in part because I am motivated by use cases where patients donate their data to research. If you're in a health institution and you want to perform research on your own patients, well, you've got access to the data sets that you might need within your own walls. Of course, you may need IRB approval, and there's other kinds of considerations, but when it comes to the data, you've got the data on your patients. But if you're running a study of a rare disease, and the patients who want to participate happen to be spread out across lots of institutions, good luck forming a coalition of exactly the institutions where your patients happen to be in order to enable data sharing. That's just a very hard structural organizational problem. But patients have have a right to request their full data set. And with EHI, they can get an electronic computable copy of that data set. So that becomes a very powerful way to bring data into research studies. You'd rather have data in FHIR for the core data set, and we've also been engaged in many projects to help individual patients connect a research study to their health records using FHIR. I should say that from the outset. That is a really great direction. It's much easier. It's much faster. It's wonderful for the core data set. EHI is a backstop to that process. It's the escape hatch. It's how do you get everything else? Questions about this concept? Is that roughly clear? Raise your hand if that was roughly clear. Okay, awesome. So as I was starting to put together slides for this talk, it occurred to me I really had learned a lot about Epic's EHI export format because my own patient records happen to all be in Epic systems. So I will talk about that in a moment. But I realized I should do some kind of quick look at what other vendors are offering. And so I wrote a small script, which I've included on this slide here. It should be in the Whova deck. And I've also included an API key here. I'm not sure why this query requires an API key, but this key is just what is in your browser if you go to the Chapel website. So it's not a secret and it's not tied to me. It seems to just be public information. So this is an API call that lets you download the full set of submissions for each certified EHR product. So this is probably going to give you a couple hundred megs of JSON for, I don't know how many certified products it is over time. But part of the submission package that a certified product will make is the URL where their export documentation lives. So you can extract that from this file and then filter it down to just the unique ones. And you get a few hundred of these. So I randomly picked 5 from this list just to have a look at the kinds of practices that we were seeing from these EHRs. And the short story here is this was super discouraging. I really did just look at these 5. And out of the 5 that I evaluated, the first one had a page, like when I resolved that URL, it wasn't a 404, but that page just didn't say anything about their EHI export format. So maybe they have one, I just didn't find the documentation where it was supposed to be. The next one documented every kind of data was a PDF, and then they're like, but also some data is XML, and like in one paragraph of text, they like described the names of the tags that would appear in the XML. And that was it. The third one had sort of a table where they listed a lot of different types of data in the first column, and then for each type they would tell you whether the data were PDF, XML, or JSON. And that was the level of structure information that you could see. The next one introduced something that surprised me, but turns out maybe it's a common pattern. Their EHI export documentation was, here's a CCDA file. So when you ask for an EHI export, you're going to get a CCDA. Same kind of summary document that we've been publishing since the requirements were introduced earlier in the meaningful use process. And then the fifth was exactly the same mistake. All of their EHI documentation just seemed to say, we will give you a CCDA. If you compare these definitions against the designated record set, that is pretty obviously, to me at least, not sufficient. It's not going to represent everything. It's a summary format by definition. I may be missing something here, so I'm very open to feedback. So if you've got any knowledge of these kinds of systems, the Twitter post that I've linked to in the thread shows exactly what these were under the hood. I'm not trying to name and shame organizations here, because my guess is this is just a much wider spread problem, and it seems pretty likely to me that the health record vendors who are implementing support for EHI haven't grappled in a deep way with what these requirements really mean. They may have misunderstood it, or maybe there's something else that I'm missing here. But I would say from what I've seen so far, it would be really helpful if at the time an EHR was preparing its submission, there was some checklist that was a way to review what they think they've done on EHI. Just a sanity check, and I think even that could probably go a long way. Because as it stands, the feedback loop is like, you get certified, you get listed in the ONC website, and then, I don't know, 2 years later, some guy comes around and starts looking at your documentation and asking questions. So there's probably a way to shorten that feedback loop. So I'm going to talk now about my experience requesting my own electronic health record information. And I was pretty excited about this. As I mentioned, I started at the beginning of 2024 when I first thought that this was likely to be available for my healthcare provider. But even before that, Epic published openly a set of documentation for what their EHI format was going to be. So that was almost a year prior, March of 2023. So at that time, Epic had a website that was on open.epic.com. They published a list of tables. I'm not going to scroll through the whole thing because there's 5,000 of these. But my understanding is this is very, very similar to Epic's internal data warehouse that they make available to customers called Clarity, and that they've done something like a one-to-one mapping, or very close, between the Clarity data model and their EHI format. Now this makes a lot of sense. There's a lot of data modeling that goes into the creation of 5,000 tables, and the prospect of creating a whole new set of structures for EHI export and trying to map into 5,000 new structures and document 5,000 new structures just for this one requirement, that could be overwhelming. So if you really are taking seriously the prospect of exporting everything, then using the schemas that you already have makes a ton of sense. If you click on any one of these, you start to get the sense there's a common structure across these table documentations. There's a description, there's a list of primary keys, and there's some information about each of the columns. This is the only format in which the information here are directly published as these web pages. But under the hood, they have a fair amount of structure to them. And it's not too hard to parse data out. So I put together a project on GitHub with the help of ChatGPT back a little over a year ago that essentially just parsed all of the data from Epic's public documentation and posts it to a GitHub repo. And this has been keeping itself up to date. There's a GitHub action that I think every night it just downloads the latest set of table definitions from Epic, checks to see if anything's different from yesterday, and if so, it publishes a new release. So we've actually had 405 releases of this project. I had no idea the number was that high, but that suggests there's been, roughly changes every day. Or my diff algorithm is wrong. Both of those things seem possible. What it outputs is a set of JSON files in a schema format that I put together without too much thought. So from the web page that we were looking at over here, this was the ABN service info file. And if we look at the corresponding JSON schema, just to give you a sense of what these look like, this is the parsed version of that web page. So same description, same primary keys, and an ordered list of columns. And I tried to preserve everything I could from that web page. If there's anything that I'm missing, that's a mistake on my part in terms of the way that I've parsed the data out. So now you've got 5,000 or so of these JSON schema-like things, just describing the tabular structures. And each of these is essentially independent. If you read the descriptions, you can get some idea that there's some relations between these tables, that in some cases they're talking about the same concepts. But as we'll see, it's not always clear what that means in terms of actually being able to link up the data. So earlier this year, I asked for EHI from my healthcare provider. I'll show you what that looks like, or what it looked like at the time from the MyChart portal. So at the time, I got timed out. I was signed in right before this session, but I took too long. At the time, my healthcare provider had a feature that you could find in the menu here in the top left. When I searched for EHI, I found 2 hits in the menu structure. And one was called Computer Readable Export. And I was able to submit a new request for a computer readable export and go through this process. And that created a request in the underlying system for my data. I saw the request in my MyChart portal for a couple days in a pending status, and then 5 days after I made the request, it just disappeared. It wasn't mentioned at all in the portal anymore. So I tried again, and the request showed up. And then the day after that, the request was still there, but the button to ask for an export had disappeared. And it turned out that my provider had turned that button off because pesky people were, depending on how you want to look at it. At the time, I figured maybe something went wrong with my export and it was going to be too hard to keep up with this process and they'd rather not have an easy button for requesting it. I've since then come to understand a little bit more about the motivation there, as we'll get to. So my request at that point was still in play. And a week later, I got a call from the healthcare provider saying, did you ask for this EHI export thing? What data are you really looking for? And I was like, I want all the data. That's precisely what I want, is the whole export. And they tried to explain that this would be, not really readable with the naked eye. It was going to be this sort of computer format and very nerdy. And I was like, yeah, that is exactly what I want. Please, give me the just lowest level nerdy data you can get. And then we fast forward a couple of weeks. I tried to write them a follow-up message, but you can't really communicate with the health information department through MyChart, and my organization, and my doctor is local to Madison where I live, but the organization is like a regional health system, and all of the email addresses were for different hospitals in different states, and I didn't know which one I needed to reach out to, so I guess I just picked one in Madison, but that turned out not to be the right one. I should have picked one in Cedar Rapids, which I eventually learned. And then it turns out that people at Epic read Twitter, and I got a text message from somebody at Epic who very graciously asked if it would be helpful if they could intervene on my behalf and ask some questions and help debug this. And I wasn't totally sure what to say. On the one hand, yeah, I did want to get the data, and I could see that that would be a really helpful step. But on the other hand, I was also trying to test the waters and understand how this process is working and not have some kind of VIP red carpet treatment. But I decided in the end, like whatever I'd learned here, like hopefully it would be helpful in fixing more systemic problems. So I said yes, that would be great. And then within a week, they had gotten an export out and ready for me to download. And there was an 8 megabyte zip file, which had about 500 TSV files inside. Of course, there were actually 5,000. There was one for every table that Epic defines, but most of them were empty. And my guess is that's kind of typical. I mean, I don't have a super complicated medical history. I don't have any inpatient care, or at least nothing I would have considered inpatient care associated with this particular healthcare provider. So maybe 10% of the tables were populated. And I got to work taking a look and trying to understand what was in there. I'll say this is still a work in progress. So after my first couple rounds of review and exploration, I started sharing some feedback. I found that there were references to data, but the data themselves were missing. So for example, I had metadata about inbox messages between different provider staff members associated with requests that I made for a medication refill. And I had the metadata and some routing notes and comments, but not the actual messages. And I had a table that mentioned a whole lot of documents that had been received in the system, some of which I could see and some of which I couldn't. I had a table that mentioned medication history that was pointing to a list of medication history data, but I didn't actually have that list. That table was just missing. Vital signs, I had a lot of metadata about when my vital signs were recorded and who recorded them and where they were recorded, just not what the actual measurements were. So like I knew exactly when my blood pressure was taken, just not what the blood pressure was. And it turns out there was just one missing table from the export. So just yesterday, I got this email back from my healthcare provider that went through my request point by point where I was sort of sharing this feedback, and they've addressed each item of feedback somehow. In a couple of cases, it was, oh yeah, we forgot to give you this vitals table. Epic has given us advice about how to do it. We've turned that on. Or we forgot to give you this medication history table, and now we've turned that one on. In some cases, the answer was, we really don't think this is part of the designated record set. We know we included some metadata that was pointing to this information, but it's not that you're missing the information, it's that we shouldn't have given you the metadata in the first place, so we fixed that by taking the metadata away. So each of those issues has been sort of adjudicated one way or another. And literally just 1 hour ago, I got access to that file. So I haven't actually had a chance to dig in and see. I was thinking I was doing this with plenty of time for DevDays because providers have 30 days to respond to one of these requests. But if within those 30 days they request a 30-day extension, then they have 60 days. And so 60 days brought us to yesterday, and then there was some glitch on the website where the file they had released wasn't actually available to me. But today I really do seem to have it. I have downloaded it on my laptop in case it disappears from the internet. I just haven't cracked it open yet. Okay, so let's dig into looking through this file. First thing that I tried to do was match up the resources, the TSV files that I had received with the schema information that was published on the Epic website. So straightforward enough. I basically took data from this TSV folder. So the export looks something like this. This is a slightly cleaned up version of the folder structure. I've redacted some information. I'll show you a quick example of a redaction script, but like my social security number, for example, and some of my wife's personal details, I've redacted from these files. But other than that, they're going to look basically like the raw information that I received in this export. It's got a lot of personal information about me, including, address, phone number, birth date, all this kind of stuff. I've been posting some version of this kind of health data for a long time, so there's not much that's new in that regard. But this is not for everyone, posting it publicly, I mean. But my calculus has been that this data is so hard to come by, it's really hard to learn about these data formats, and so I could do a lot of good just by publishing my own small amount of personal information in a format that gives other people a very concrete sense of what's here. Because the documentation you get from Epic doesn't have any example instance data at all. And it can be really hard to tell from that source what the data are going to look like. So one thing you'll notice if you scroll through these TSV files in my GitHub repo is that lots of the columns are empty. And that is a pervasive theme. And I'll say it can be very hard to tell why these columns are empty. I believe that in some cases, the provider who's doing the export has kind of knobs and dials, depending on what they think or what they've determined is part of your designated record set. So Epic provides them some kind of base configuration, but then they can further configure which tables they want to expose and which columns they want to populate. I'm not completely sure about this because it's a black box. I don't know what they've turned on and off, but I can say that most of these columns, or many columns, are missing in a lot of tables. This can be particularly frustrating when I'm trying to debug some information. I'm not sure if something is missing because there was a glitch or missing because there was an intentional decision that this particular piece of information wasn't meant to be shared. But I essentially wrote a piece of JavaScript code that would just read each of these tables and find the corresponding JSON schema that I had produced earlier in the year and take those things together and mash them up into the kinds of files that you'll see here in the JSON folder of my Git repo, where these files have at the top a key called $meta. That has all the schema information about the table that's represented in this file. And then at the bottom, it's got an array of JSON objects. So in this case, this is the account file. So it's got an account key and then an array of account objects where I've just used the column names and values here. And I'll say for the most part, this worked pretty seamlessly, just using the versions of these schema that came from the Epic public website. But there can be version drift here. And my export itself actually came with a copy of that whole documentation website from Epic. And so maybe the best thing to do would have been to reprocess that copy, the snapshot of the documentation, in case any columns had gotten out of sync. For the most part, these things lined up. There were some systematic differences that kind of make me scratch my head. So like, there's a lot of these YN flags where you're saying yes or no. This is essentially a representation of a Boolean. And in the underlying documentation from the Epic site, there's descriptions where there's this list of category entries. This is basically what FHIR would call a small inline value set. So sex, the category entries are male, female, unknown, non-binary, X, and other. Is active, the category entries are yes and no. And usually these category entries correspond to what I find in my data files, but for all these yes and no ones, my data files only have Ys and Ns. So, okay, that's just like a little quirk. And you learn that, it's Y and not yes. That means the Boolean value is true. The other thing that I started to notice pretty quickly is that the underlying formats that you get from Epic include things like this: account, account_2, and account_3. And if you go ahead and read the description on these things, account contains information about billing for services, contains one row for each account record in your system. Okay. Account2 contains information about billing. This table is the continuation of the account table, okay? And account3, this table contains one row for each account record in your system. I assume this is actually the continuation of account2, although that's not explicitly stated. And there's a lot of inferences that you need to make. Account is maybe one of the simpler examples here, but if we look for _4s here, we can see the things that there's at least 4 or 5 of: claim information, claim values, coverage, hospital accounts, in-basket messages, orders. There's 7 different order tables. And you get comments like, this table should be used with order med. I assume that that means that each row in this table corresponds to exactly one row in the order med table. So what I did is started putting together some scripts that could merge the information from these different tables, because for my purposes, the splits were a bit arbitrary. So I tried to find some heuristics for figuring out which tables were part of a sort of mergeable group. One of those heuristics is like they have the same name, and then if you delete all the underscores and numbers, the names match. And that's like a decent heuristic. But sometimes when table names are too long, the Epic table names will be abbreviated, so you might change account to ACCT. So just checking for exact matches there is not good enough. You need a few more heuristics. And eventually, I just wrote a script that tried to cross-compare the data in every table and see if there was a unique one-to-one mapping between the rows, and sort of use those as candidates for which tables could be combined or merged in this way. So in the case of this account.json file, if you scroll through the schema, you'll see some of the columns here, I have annotated them as merged from account 2 or merged from account 3. And that was just my bookkeeping to say, I only want one schema here for accounts, but I'm going to keep track of where the columns came from. And then in the instance data at the bottom of the file, I mentioned we have this array of accounts. Well, this first account here, if we scroll through it, we'll see that some of these properties actually were merged from the account 2 table. And I just inserted these little JSON comments as a note to myself. And I set this as a key just so that when I'm reading these things top to bottom, I can see what came from what. And so we can see that we merged in data from account 3 in my case, but there was nothing actually new in account 3. Now the account 3 table wasn't empty in this example. If it was empty, I would have filtered it out from the very beginning. So what's going on here? If we look at the TSV files, account 3 has an account ID, and so it's not empty. But that's literally the only thing that has in my example. And again, I'm not sure if it's just that my healthcare provider doesn't use any of these fields or they elected not to export those fields. But there were many tables actually for me that were purely overlapped or redundant with other tables. They may have had 2 or 3 columns populated, but nothing new or different. Okay, so what can we actually do with these data? You know, we've merged the tables that can clearly be merged. Let's start thinking about how we could browse the data in a more coherent way. So I have a very simple take at this task here in this web application called My Health Data EHI WIP. So that's on my personal public website. And I've just listed all the tables here in the sidebar. And you can browse through the data by, say, turning on the account. And we can say, great, this is the same information we were looking at earlier. These are all the different columns associated with my accounts. What's linked to an account? Well, this was not super obvious from reading the documentation. Like, I have this account record here, and this account record here. 2 accounts associated with my own export. But there's a bunch of things that point to accounts that are maybe child tables of the account table, if you want to think about it that way. So what street addresses are associated with the account? Or what insurance coverage is associated with the account? Or what transactions have been performed associated with that account? I knew I wanted to be able to browse the data. The data themselves form this kind of web. They're linked intrinsically, but it actually was not clear what tables were child tables of the account table. So if you read the documentation, as we were looking at earlier, if you open up the account table, there's no real hint about what links to or references accounts. All we know is these are the columns in the account table. If you scroll, you can look for tables that start with ACCT, and you could say, well, those are probably related in some way to accounts, and that is generally sort of true, but it's not always obvious what way they are linked. So I was looking at account transactions. So this table has an account ID and a line, that's the primary key. And so eventually I started sort of learning this pattern where if there's a primary key that sounds like it's coming from some other table, and I can guess what table it's coming from, this is probably a child table of the account table. Doing those kinds of annotations by hand was really painful. With 500 tables, there's a lot of cross links. There's a lot of nested and linked data to work with. So I started putting together some heuristics for that, sort of computing what could plausibly be a child table based on whether the primary keys lined up. So if you have a table with 1 primary key and a table with 2 primary keys, and the values of the first table always show up in the second table in the first slot, you can start to say, okay, the second table is going to be a child table of the first one. And so I started annotating my JSON schemas with what I'm calling kind of discovered or inferred relationships. So again, for the account table, I already showed you that I was able to merge in properties from a few different tables, but there's also something that I call discovered mappings. So for every table, I really just did this in a brute force way, figured out everything that could plausibly be a child table, and then tried to sanity check. So there's code that does all this in the repository. So I said the account table has a child table called account creation, another one called account address, coverage, patient information, transactions, and so on. So those are all, what I'm calling discovered child tables. And then there's foreign keys. So when we're looking at the data in something like this browser, maybe there's an immune ID, or maybe there's an account ID associated with one of these records. So here's my account coverage table, right? There's a table of account IDs and a table of coverage IDs. This is a child table of the account table, but how is it related to the coverage table? Well, this is a simple foreign key reference. This is really hard to discover from the schemas alone, but if you just look up this number, just copy this and search all the files for it and say, what files does this number appear in? Okay, when does it appear as a primary key? That pretty quickly gets you to the point where you can say, okay, there's a foreign key relationship between that column and a table called coverage. So this is the kind of heuristic that you can only run if you have instance data. So I've been able to discover a lot of relationships between the tables in the set of 500 that I have data in, but there's 4,500 other tables that I don't have data in, and I really don't know how their schema are related because I can't run these heuristics. So that's been a little bit challenging, but I've at least been able to make some progress on the files that I've got. So after I discovered these kinds of relationships, I started trying to write down schema in various computable ways. One thing I put together is an SQLite database. The real motivation for an SQLite database was because you can describe the data and also document all of the foreign key relationships and table relationships all as part of an SQLite schema. And so one thing I did was just to upload that thing to ChatGPT and say, here is an SQLite database with all my health information. You can query it to try to answer questions. By default, it's not very good about reading the documentation. So I have a whole bunch of prompts for this custom GPT that are all focused on trying to get it to query the SQLite metadata tables to read the definitions that it needs to see. And I've been talking at you all for a long time, so let me try to do a live interactive session here. I'm going to ask ChatGPT some question based on my health record. Anybody have a question that I should try asking? You can ask anything you want. It probably won't work, to be clear. This is not like a super robust system, but you can get some intuition for sort of what it can and can't do. Allergies. What shall I ask about allergies? All right, what are my allergies? This is a good question because it's very plausible that it might be able to answer this. It's a bad question because this shows up really well in my FHIR export. So allergies are really well covered. But so, ChatGPT is able to do a pretty good job of connecting to the SQLite database, querying for tables that have the word allerg in them, and there's 5 of them. Very good. And it says, I'm going to look through some of these tables. I'll check the schema of the Pat allergies table. And so it reads that schema definition. It's all on one line, so it's not that convenient for us to read live in the session. But this describes all the columns in that table. And ChatGPT then actually parrots it out for us to see. Then it's going to proceed to try to write a query against that table. It's going to try to follow these allergy record IDs into the next table. Now we've got a join between Pat allergies and allergy. So, maybe it's gotten somewhere. Actually, not bad. We got to the point where we've got these allergens, which are indeed things that I'm allergic to, severity status, and active status. I've retrieved the details of your allergies. Okay, so that was actually a pretty decent performance. It's kind of magical when this comes together. There's a lot of places where it fails in spectacular ways, in part because the documentation that I'm passing through is quite verbose. And it can be a little hard to tell what's happening under the hood when OpenAI implements this kind of interactive paradigm. I'll come to you in one sec. Under the hood, OpenAI is letting the model write these queries and read the responses, but it truncates them silently in some cases. And so sometimes that's the reason why 3 screens later the model is making up properties and column names that don't exist. It's not always that it's pure hallucination. Sometimes it's not actually given the information it's supposed to see here. So I started thinking, okay, how can I have a little bit more control over this process and not leave everything to the whims of this kind of pinball machine ChatGPT interface? Question from Dave or comment? Oh, you're getting the microphone. Hold on.
So Hugo Campos did something like this.
Yes.
And a really practical thing for him was he was trying to remember, when did I have that super high blood pressure a few years ago? Can you do something like that?
Let's see. When was my highest BP reading and how high? So I'm going to let that run. Actually, I'm going to put that on my clipboard too, because the other thing that I started working on was kind of a hidden feature in my data browser here. I was really interested in seeing, like, could I represent the information from these tables in a way that language models would be able to process them effectively kind of in this interface. So I've got this like fake little slide out here by the scroll bar. The rest of this demo you can try at home and it'll just work. This piece here will only work if you run a local proxy called Light LLM on your machine on port 4000 in its current state. But basically what this does is it allows me to try to figure out a set of tables that are relevant to a question. So I'm going to click this little magic button and I'm going to paste in this question about the blood pressure. And it's going to write a language model query to try to figure out what tables are relevant for blood pressures. And it's picked a few. Oh, crap. This is a terrible question. I mentioned this to you earlier. I can't answer questions about my blood pressure because those numbers are still missing from my EHI export. I could tell you what the blood pressure was, but I can't tell you what it was or how high. So we're going to have to pick something other than blood pressures. We'll go back to allergies for the example here.
Allergy episodes?
Well, there aren't any in my record. I happen to know that. But I'll just say, what am I allergic to? So this first stage here, we're just trying to figure out what tables are relevant to answering a question. And so, okay, we picked out the allergy table, the allergy flag table, allergy reactions. That's pretty good. So over here, let's reload and see what's going on. Over here, there's a block of prompt, which I'm not going to go through in any detail now, but it instructs the language model about some objects and functions that it can use and call, and gives it some suggestions about how to work. It's all documented in the GitHub repository. And now I'm going to say, here's what to help me with. What am I allergic to? And there's a few different language models on the back end that this can call, but GPT-4o is pretty fast and pretty good. So I'm going to use that. And you can get a sense for what the model's going to do. It's got some table definitions in scope. These ones that I've selected are the tables that the model has been told about here. Under the hood, what's happening is the model has been given TypeScript schema for all of these tables. And the schema have been decorated with links between the different tables so that instead of having to write complex SQL joins, the model will just see a property called like these lowercase property names, which link to other tables. So it can just follow JavaScript properties by using the dot syntax, object A dot B, to follow a link to another table. It's an implementation detail, but the goal was to try to avoid requiring the model to write these complicated joins. So the model turns around and says, great, here's our analysis plan. We're going to find the allergies, we're going to gather allergen information, we're going to output the results. So step one, identify the allergies. And it writes a little bit of code. It's going to retrieve the allergies by using this DB object that I gave it and calling the pat allergies method. And under the hood, I'm running this code automatically, but I'm not returning the result to the model yet. Instead, I'm just giving myself a little button that I can click to see what the result was. And in this case, there was an error. So I'm just going to send that error along to the model and let the model figure out what to do next. It says, oh, I made a mistake. It used lowercase pat allergies instead of uppercase. Great. So now we're going to give it the result of that code, which looks like a block of JSON. Looks like different allergens that were entered at certain times by different users. So it says, great, now step two, I'm going to gather the detailed information about the allergens. I'm going to write a JavaScript map over these functions. And again, there's some kind of error in this because it's trying to refer to a variable that it defined in the previous block, but my instructions are you have to write complete code every time. I'm not keeping any state. And apparently the model didn't really follow those instructions very well. So we can go through this sort of step by step and provide feedback, and the model can correct the kinds of queries that it's writing at each stage. So since the code blocks run in isolation, the model says, we need to repeat the first block. Yes, that's exactly right, we do. So it runs the fixed code. We get a result out here that looks closer and closer to a narrow list of the allergies that I have. And then it's probably going to come up with some kind of final summarization of what the allergies were. So this is an example of about how far I've gotten working with my EHI. It's been a lot of fun to play with. I've learned a lot about the data formats. I would say the documentation that Epic has published is head and shoulders above what many other EHR vendors have done in terms of level of detail, but it is still missing things that are absolutely essential to be able to correctly process the data on the other side. I've really put in like a lot of effort to try to guess and make these connections for myself, and I'm not maybe doing it justice, but I spent a lot of time just getting to the point where I could vaguely get this to work. And okay, we got a reasonable summary out of the language model here. For anything really complicated that's bringing data together from multiple tables or areas of the record, these structures are hard to work with. I think even if they were very, very well documented, it's still a little bit beyond what today's best language models can do, but there's clearly signal here. And as these models get a little bit better reasoning power, I think that's going to become squarely in the realm of the possible. So that these data sets, even though they're messy and even though they're large, and even though each EHR vendor might have a totally different format, I think we're going to get to the point where patients donating their data for research can say, here's a pile of data, I'm not sure what it all means, but researchers can come and ask questions like this and get a reasonable level of analysis. So that's the content that I've got for you today. I know that we're at time. I didn't save enough time for questions at the end, but come grab me at the social hour. I'm really happy to talk about any of this stuff in more detail.